are just now at the hour, so thank you so much for joining today. I'm really excited to talk to y'all about our Labdisc. So this is our all-in-one sort of portable science lab, and I'm going to go over 3 really easy, really fun experiments you can do this summer. Some are short-term, some are long-term, but we hope you will get a chance to learn something new, get inspired, and get excited by some of the lesson plan experiments that I'm going to be sharing today. So let me just start. Nope, that was the wrong button. All right, let me just start sharing my screen. And I'm going to pull up the chat so I have that available. Anyone who is here, please change your chat settings from just hosts and panelists to going to everybody so we can have a whole conversation going. But like I said, I'm so glad to have you with me today. I see some repeat faces here, so it's good to see you again. I'm going to jump in and get started. So first things first, if you have not yet filled out our summer survey, we're taking a summer break. We're going to be coming back in the fall, and we want to hear from you about what times work best for you. So if you haven't filled out this survey, the link is at the bottom of the screen. I've also dropped it in the chat, and we'd love to find out, not just for the people who are attending live, but those who watch on our YouTube as well, if there's a specific time of day that is best for you to join in the fall. We also have a field on there for different topics that you might be interested in. So just throwing that in there. I'll put it up again at the end of the session, but we do want to know what time works best for everybody. So feel free to share in the chat what grades you work with, as well as what your role is as an educator. Do you work in a school, a summer camp, after school? Are you one of our wonderful partners? Are you more of a teacher support? Any of those things can help me direct the conversation more towards you. Just seeing some of the names I recognize, I know we have some partners here. I know we have some educators here. So thank you all for being, and I will direct what I have to who you are, as well as anything that comes in for the chat. So first, experiment number 1, stylish shades. I have lovely sunglasses here that I will not wear for all of the session because they tint the world with rose-colored glasses, as it were, which is a little bit interesting to look through. But this experiment is all about designing and making your own pair of stylish sunglasses, and we use the Labdisc to evaluate just how well the sunglasses work to block out both light and UV, or either one, depending on which Labdisc you have. If you happen to know which model of Labdisc you have, let me know that in the chat as well. So the one I'm holding up here is our GenSci Labdisc, but I know we've got some schools with like the Biochem or the Enviro or the Physio, and they have some overlapping sensors, but not all of them are exactly the same. I'm also just going to do a quick check right now and make sure I did start recording. Okay, I did. Perfect. All right, so how you do this experiment. First things first, materials list. So you'll need a Labdisc. That way you can evaluate the effectiveness of your pair of sunglasses that you make. You'll need something for the lens. So I just used a colored cellophane. You can see behind me in our next experiment that I'm going to be talking about. Cellophane comes in a whole variety of materials. You can just get a combo pack that has a whole bunch of colors. So that's what I'd do, really cheap on, online retailers or craft stores. And then for actually building the frames, you can either use a 3D printer, like our Robo 3D printers, or you can do what I did here for a low-tech or faster turnaround kind of option, which is craft foam and craft sticks for the parts that go on your ears. So if I were to do this with a 3D printer, I would have the students design the part out of craft foam and probably still use the craft sticks for going back, unless you wanted the students to design the full glasses. And that would depend on the age of the students you're working with, as well as how long you're going to be with them. So if this is a multi-day camp, you actually have some turnaround time to print glasses. But if it's a one-day session or one-day special activity, you may only have, a little bit of time with the students, which is where the craft foam comes in. And then for either of them, you're going to want tape or glue. You're going to want some sort of scissors as well as markers. So experiment step number 1. First, this is where the Labdisc comes in. You test all the different colors of cellophane for either how much UV or light gets through to see which of the colors block the most of each light. Then the students design and make their glasses, taking into consideration what they learned about the different colors of cellophane. And step 3, students look super stylish. So step 1, testing all the colors of cellophane. You can see in the sample picture here, I have a GenSci and an Enviro. So the GenSci, the Biochem, and the Physio models of Labdisc all have a light sensor. So if you are using the light sensor, you'll be testing for how much light gets through your glasses. The Enviro doesn't have a light sensor, but it does have a UV sensor. So if you have the Enviro Labdisc, you can test for UV instead. And if, like me, you have both, test for both and consider both when you're making your design. Now, you also may notice in this photo that the GenSci Labdisc is sort of sitting right next to a cardboard box. That's because if you take these outside and you point them directly at the sun, they will probably oversaturate the sensor and give you a reading of just like sort of capped out. So if you stick it somewhat obscured or occluded by a box like I have in that photo, it'll drop the readings to a level that you don't have to worry about having anything that's oversaturated. And for this part of the experiment, I would just read it right off the screen. So you can see the Labdiscs have a really nice screen. You just click on the sensor you want. In this case, I'm looking for the, little sun icon. And when I click on that, it tells me my light readings in lux. And if I put, say, some red cellophane over that light sensor, the value on the screen goes down. Once you have your test and you know your numbers and you've chosen your colors, and you can have students even try like mixing and matching. Maybe they do 2 layers. Maybe they do a red and a blue, or a green and a red, or a yellow and a blue, whatever it is, or even 2 yellows, You can choose how much experimentation your students can have with this and what they're trying to optimize. If they do too many layers, maybe you can't see anything. But once you've chosen and they've, decided what they want, both in terms of what its physical appearance is, as well as what it feels like to wear them. Like I said, everything here becomes very red looking to my eyes, which is kind of interesting, but not something I'd want to wear all day. But once I choose, take the craft foam, and I would fold it in half, just like if you're doing a heart and you want the heart to be symmetrical, you fold the piece of paper or foam or whatever in half and then cut around that. Do the same thing for the outside of your glasses so that they're symmetrical, at least if that's part of the design. Then line up or draw out an inside or cut your first inside, and then you can use the marker to trace on the other side. And the nice thing about craft foam is it's flexible. So even if you're working with really young students, they can just sort of bend the craft foam, cut it with scissors, and then cut the inside area out. If you're doing this with kindergartners, you may want to help with cutting out the inside of the glasses, but it's still such an easy material that it's not too challenging for them. Add the cellophane, tape it all in place. You notice the craft sticks are actually secured between 2 layers of foam here. That way the tape isn't like rubbing against my face or the stick, it's staying in pretty well. And if I was doing this, like I said, with a 3D printer, I'd just have the students design slots that can fit predetermined craft sticks. So you don't have to worry about doing a 3-dimensional design. You can just do the flat face. So that's one of the ways I would age this up, is have the design challenge be a part of it if possible with a 3D printer. Or maybe your students are just designing something with a few more restrictions. One thing I noticed when I built this without very many measurements at all was I created the gap between the eyes really far out. So it looks a little silly because the glasses probably should be a little closer over the bridge of my nose than I designed them. And so you could have students be taking measurements with calipers and really seeing what would be ideal for their face shape and things like that. So a few things to keep in mind as you are doing this activity. And then step 3, look super stylish, do a photo shoot, look absurd. It's great. All right, experiment number 2. So that is the one we've got behind me on this table here. And of course, when I was running the experiment live, I had these blinds much more open, but I didn't want to be a complete silhouette in the window today, so I've got them closed just so you can see me here. But the purpose of this experiment, this is a longer term experiment, so better for summer camps that take, 1 to 2 weeks. The experiment really is designed to last over 2 weeks. So this is for summer schools or longer programs. But the purpose of this one is to find out how all different colors of cellophane impact the growth of plants. So if you were to, cover a greenhouse in a color, what color would be ideal? So the materials you're going to need for this one are, the Labdisc again, the cellophane, either a 3D printer or like chenille stems, pipe cleaner type things, straws, some tape and scissors, markers, either cups or jars to plant your seeds in, and then of course paper towels and seeds, which is what is actually planted. So this one here is an example of, you can sort of see I've got paper towels in at the bottom here, and then the seeds are pushed up against that. Now, the good thing about this lesson is that we have this lesson plan already fully ready in our My STEM Kits platform. So you don't have to be necessarily taking notes or anything on this. You can just go pull up the lesson plan that's already written. We actually have one for 2nd grade and one for 5th grade. And then it'd be super easy to adapt to older grade levels as well, with just how you integrate the math and the measuring and the data that you're collecting throughout the experiment. So the main concept of the experiment is build your greenhouses. Use your Labdisc to test the temperature and light, or just like in the last experiment, UV, in each of your greenhouses. Plant your seeds, form your hypotheses, and then run the experiment. Track your seed growth over 2 weeks. So this is a really good chance for students to practice experimental procedure, longer term experiments. So you're obviously seeing how plants develop and grow, but you're also testing additional things, keeping a journal, like a scientific journal of what you're seeing and documenting each day. So it's really good for those writing standards as well. But to build it, we have detailed instructions in the lesson house, but step 1, build the greenhouses. You leave one side of the greenhouse open. So I'm going to just pick up this one here. So I can stick my hand in one side. You want to be able to access the inside of a greenhouse, but all the other sides should be covered. That way the plant is fully obscured by whatever color it is. And then we are using 3D printed connectors to make these corners and straws to make the essential like lines on here, and taping it all in place. If you don't have a 3D printer, you can just use straws and either like pipe cleaners or tape to do the corners. It just might be a little less precise, which is totally fine. But if you have a 3D printer, you might as well 3D print the corners. Step 2, test the temperature and light or UV. So with this experiment, you start with some data like, what is each environment like? And so you put a Labdisc in each of the different colors you're testing, and you set them all in these either 3D printed stands, or you can prop them up with found materials, again, if you don't have a 3D printer. But you put it in the stand and you make sure that the light or UV sensor is pointing up at the ceiling. That way your light readings are consistent. The light sensors are located in different places depending on which model of Labdisc it is. So you don't want some of them pointing up, some of them pointing sideways, and so forth, just to make sure your data is more consistent. And then you put them in there with the external temperature probe that you can see in the images, and I have one here. Just plug that in to the port on the side of your Labdisc and let it sit in the greenhouse for a few minutes so it can acclimate to the temperature. The external probe is going to acclimate very quickly, and you will see, a few degrees temperature difference between the different greenhouses. Now, we intentionally include a greenhouse that is black, that blocks most of the light. And so This is to address standards of like plants need light and moisture to grow. So you see I have a little door here that's just taped in. I cut out an extra piece of the paper here, created a door. That way I could peer inside, get the readings off my Labdisc, but not have to expose the plants or anything to sun, because obviously if I took this off to get the light reading, it wouldn't be accurate. So you collect all those readings. Again, we're keeping this one outside of the software, just using the readings on the screen. But if you wanted to, you could do this all in the software as well. That way you wouldn't even have to create that little window on the black one to see your data. You could just be connected to GlobiLab on your laptop or your device and view the data there. Once you've tested it, you plant your seeds and form your hypotheses. So if you notice in these pictures, we have one cup that's labeled wet, one cup that's labeled dry, and we did 4 seeds in each cup. For the wet seeds, we actually soaked them for anywhere from 5 to 8 hours before planting them. That way they have time to start the germination process and just speed up your experiment. The dry ones, we leave completely dry. We add no water to the paper towels, versus the wet ones, we pour a quarter or a half cup of water over the paper towels once everything's been planted. And then you label the seeds A, B, C, and D. That way you can track all of your data really well. And we do 4 seeds just because not every seed is going to germinate. So it just increases the odds of having some successful germination in every environment, or at least every environment that is going to grow. And then, like I said, track the growth over 2 weeks. And this is where your variation from different grade levels is going to work. In second grade, in the second grade lesson, we were tracking data just 1 day at a time on dot plots. And then in 5th grade, we were doing it on line plots. So tracking it on a number line, including fractional values. So we're measuring in centimeters to the nearest 100 or to the nearest 10th. Also doing some conversion there with millimeters to centimeters. And then if you're working at this at an even higher level, you can start evaluating the shapes of the lines, the shapes of the curves. You could be measuring the size of the leaves as well as the growth of the plants. So I would say to adapt this to higher grade levels in elementary, it really comes down to the math integration that you are doing. But what you've got behind me is a little over 2 weeks worth of growth now. And some of my plants have actually grown beyond the height of my greenhouses. So I've started adding little spacers at the bottom. That way the whole plant is still surrounded by the color, but there's just a little bit of a spacer at the bottom. And this didn't happen within the 2 weeks. It was only after the 2 weeks ended that I started having to make my greenhouses taller. And I did this with pinto beans, but you could do this with any variety of quick growing plant. And now for our very final experiment. This one is number 3, Dear City Council, look for a way to make a more wildlife-friendly city and write an appeal to City Council with a proposed solution. So this works if you are in a city, but if you are a summer camp or an after-school program that has your own property, or even on your school property and you have control to make changes, you could just have them write a proposition to the camp director or the school principal, whomever. It doesn't necessarily have to be a city solution. So you can adapt this to your environment as well. But with this one, the materials you're going to need is a Labdisc, and then either pen and paper or email, either markers or some sort of like a CAD, computer-aided design software, and then possibly a camera, like a smartphone camera would totally work. But in this experiment, we have the students first start by discussing what plants and animals are native to your area, what they need to survive. You go out, you take a walk with your Labdisc, collecting environmental data and looking for, places that are more wildlife friendly versus not as wildlife friendly. So with that, identify an area that could be improved, draw up a solution, and then pitch it to the proposed city council, principal, etc. So for the discussion part, you can just Google on your, interactive flat panel, what animals can I find in my city? So I looked up urban animals to see in Denver. And I also pulled up a birding app that I have and wanted to see what bird species I could find in the Denver area. And so you can see there's 190 species observed in the last 7 days. That's a lot of species to consider, and that's just birds. So we know about squirrels, but there's also mice and bunnies, and in some mountainous places we get deer and mountain lions and coyotes and bears that just wander into our cities sometimes. So, raccoons are pretty common in different places, So thinking about what you can find and what we want to do to either encourage or discourage animals from being part of our urban environment. We don't exactly want bears and mountain lions wandering into cities, but other plants and other animals we do want to have in our cities. So once you have a better idea for that, go take a walk with your Labdisc. Now, all of the Labdiscs, except I think the Physio one, have a GPS sensor on them. So if I click on the GPS here, it would pull up my latitude and longitude, and you can actually view the data you're collecting right on a Google map. So with this one, you're going to be using the GlobiLab software, and you can tell it to test a whole bunch of different things. This map is showing ambient temperature, and you can see how it's hotter here in this sort of busy intersection. And the further they walk into the park and the longer they are in a park, the cooler off it gets. And so you would have your Labdisc testing probably temperature, humidity. You could do other things like barometric pressure, but just sort of comparing which areas are better or worse suited to inviting, cooler climates, wildlife-friendly climates, all sorts of different things here. So just sort of look at the data you are getting. And then identify an area that could be improved and draw up a solution. So this is a park I took a photo of a couple years ago that to me just seemed so brown and concrete. So what could I do to improve it? Maybe we put in a small pond and plant some grass. Maybe we add some pollinator-friendly wildflowers to these mulchy areas. And so students here can just take crayon or colored pencil. They can draw it up with markers. Or, like I said, you can actually draw this up in something like a CAD software such as Tinkercad, depending on the age of your students and how complex the solution is. This would be more of a simpler, like here's a generic solution. But if I'm doing this with high schoolers, I want to know budgets. I want to know materials lists. I want to know upkeep. How is this going to be maintained? All that sort of stuff. Because at that level, your students should be thinking not just ideas, but practicality as well. And so lastly, create something to pitch the idea, whether it's a letter, an email, a video, include your drawings, include your sketches. This picture here is taken from in my STEM Kits, we have a virtual kit on urban planning where you can design cities and put in different little pieces. That's on our urban wildlife kit. And so there's a virtual simulation where they could mock up things as well. So I've mentioned my STEM Kits a couple times throughout this. This is where you can go to find some of the lesson plans I mentioned. I'm putting that link in the chat, but feel free to visit this. Some of you already have accounts. The lesson plans I talked about today were red, yellow, or greenhouses and optimizing bean growth. Those are the two for the one behind me. Brand new this week. And then a walk through the city for middle school is very similar to the Dear City Council one I discussed today. So thank you all again so much for joining for this session. The Labdisc is part of our MimioSTEM solution. And so we have, our Robo 3D printers, we have our Labdisc all-in-one science labs. And we hope you have a great time this summer getting to do some more fun, more hands-on experiments with your Labdisc. So thank you all for joining. Here is that link again. If you want to put in your pitches for next year, for what time STEM Wednesdays should be, this link is case sensitive. So just be sure to type that in and put in your suggestions there. Lastly, we are taking a summer break, but we have one more STEM Wednesday before we do. Join Jillian Dale next week, same time, for her session on prepping for summer break, which will go over some more fun instructional ideas as well as some practical tips for getting ready for the summer season. Thank you all so much. Have a great day.